All right, and welcome back. So today we are going to be going through section 4.2, which is talking about some ways to prove triangles congruent. We're going to get sassy today. So put on your seatbelts, and by the end of this video, we're going to prove two triangles are congruent by using the SSS postulate, the SAS postulate, and the ASA postulate. So have out those guided notes. Let's begin. So if two triangles are congruent, then you know all 6 pairs of corresponding parts are also congruent. But are there easier ways to tell if two triangles are congruent than comparing all 6 pairs of corresponding parts? Again, those 6 pairs are composed of the 3 angles and the 3 sides that are going to be composed. Well, we have one way. We call it the SSS postulate, or the side, 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 but we just abbreviate as SSS. So the SSS postulate states that if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are going to be congruent. So if we have 2 triangles, bear with me here, and this is 4 by 6 by 8, and we know that they're going to be congruent, well, this could be 4, 6, and 8, and we would say that these 2 triangles, just call it triangle A and triangle B, those 2 triangles are going to be congruent because of side, side, side. All sides are going to be congruent, or we say SSS. The next 2 postulates use the following terms to describe parts of triangles. So segment XY is opposite of angle Z, and angle Y is opposite of segment XZ. Angle X is the included angle between segment XY and segment XZ, and segment YZ is the included side between angle Y and angle Z. So using this general information, we're going to be able to use 2 more relations. Let's get sassy. We can use the SAS postulate, or the side angle side postulate. So if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the triangles are going to be congruent. For example, if we look up at triangle XYZ, we could have this type of relationship, side angle side. Then we could have the angle side angle postulate. Let me erase above. The angle side angle postulate tells us that, hey, if 2 angles and the included side of one triangle are congruent to 2 angles and the included side of the other triangle, then the triangles are said to be congruent. So again, if we have this type of relationship, angle X, segment XZ, and angle Z, we could abbreviate again with the ASA. That's totally fine. So SAS postulate, ASA postulate. So, for example, can the 2 triangles be proved congruent? If so, we're going to write the congruence and name the postulates used. So we have these 4 separate cases, and we need to see, hey, can we have a congruency statement? If so, what is it going to be, and how do we know? So A, since the vertical angles of POS and TOR are congruent, then we're going to have triangle POS is congruent to triangle TOR by the SAS postulate. And they mean this angle and that angle right there. So we have 1 tick mark, congruent angle to 2 tick marks. Well, likewise in triangle TOR, we have 1 tick mark, 1 angle, and then 2 tick marks. So we can use side, angle, side. And notice how we go in the same order. Side, angle, side, side, angle, side. 1 tick mark to our angle to 2 tick marks, 1 tick mark to an angle to 2 tick marks. For B, since we know that segment AC is the common side, then we're going to have triangle ABC is congruent to triangle CDA by the SSS postulate. And what it means by that is we know that AC is going to be congruent to itself. It's a common side. So if I give that 3 tick marks, because I know that that's going to be congruent to itself, we have 1 tick mark, 2 tick mark, 3 tick mark, and then in the same order, 1 tick mark, 2 tick mark, 3 tick mark. For setup C, we can say that triangle PQR is congruent to triangle STU by the angle side angle postulate? Well, if we go from our right angle, we go this way. We're going to go right angle, one tick mark, congruency. So here, right angle, one tick mark, congruency. And lastly, if we're comparing triangle EFG to triangle EHG, you find that two sides and the non-included angle of triangle EFG are congruent, and two sides and the included angle of triangle EHG. So since this happened, there's no congruence that can be deduced. What it means is, here we go. Let's say that segment EG is congruent to itself. So if we give that 2 tick marks. In the top triangle, we're going 1 tick mark to 2 tick mark to an angle. But for the bottom triangle, we're going 1 tick mark angle, 2 tick mark. It's not the same order. We would have to have the same relationship, either side angle side or angle side angle. We cannot pick and choose. We do not have a side side angle or an angle side side. That does not exist. So with this in mind, please work on problems 1 through 11 on the guided notes. You're doing great with this. Let us know if you have any questions. Talk to you soon.